we want to look at the quadratic formula. Now, you get the quadratic formula in your formula sheet. For example, in the CSEC Mathematics exam formula sheet. Now, let's just be reminded of a few things. The general form of a quadratic equation is this, right? ax squared plus bx plus c equals 0. This is not the quadratic formula, it's just a general form. We also have to remember, before we start, that when a quadratic equation is in the form of a perfect square, it is in this form. X plus h squared is the same as x squared plus 2hx, a number multiplied by x, plus half of that number squared, because half of 2h is h, and of course h squared is h squared. What we want to do, we don't just want to write down the equation and say, yeah, there it is, let's use it. We want to build that equation, alright, or that formula. That formula can be used to solve any quadratic equation, but we want to build it up. So remember, now we build that formula by completing the square of the general form. Ax squared plus bx plus c equals 0. So let's do that. The general form is, it's a different color, is ax squared plus bx plus c equals 0. Now, we want to have part of this in the form of a perfect square, the parts with x's, alright? So, when it's in the form of a perfect square, what you have is x squared, not ax squared, and so on. In other words, 1x squared. So we need to factorize and put the a outside of a bracket, so we have x squared alone. So we have a, we have x squared. If you remove the bracket, you're going to have a times x squared, give you ax squared. Good. Plus something times x. A times what you were going to write in front of x will give you b. What is it that you're going to write in front of x? A multiplied by something gives you b. So if a multiplied by something equals b, then that something, whatever it is b over a. You divide both sides by a, I have b over a. So a times b over a multiplied by b over a cancels a, so you get b. So it's b over a that's going to come here, right? It is b over a. Plus, we leave some space and put plus c outside the bracket equals 0. Now we're going to add half the coefficient of x and square that. The coefficient of x is the number that multiplies x, and the coefficient of x is b over a. What is half of b over a? Half multiplied by b over a. Remember your fractions now. 1 by b up top gives you b, over 2 by a down the bottom gives you 2a. So it's half of b over a is b over 2a. And then square it. Just like we have 2h, half of 2h is h, then h squared to make the perfect square. We square this and add it. So it's b over 2a squared. Good. It's b over 2a squared. Alright. Now we have a little issue here. This b over 2a squared was not there before. That means you change the equation. We're going to have to remove it. We're going to have to subtract what we just added. But then the thing is, we already have what is inside the bracket exactly how we want it. So we're going to have to come outside the bracket and subtract it. Alright, so we go outside the bracket. If we say, this is C, we added b over 2a squared, so let's subtract b over 2a squared equals 0. But then there's another thing. Whatever is inside the bracket is multiplied by a. So when we go outside the bracket, looking from outside the bracket, what we really added was a b over 2a squared. So we're going to have to subtract a b over 2a squared. Alright? Now, inside the bracket here, notice it's in the form of a perfect square. The x square and the x square. The number in front of the x number that multiplies x, we have the number that multiplies x. Half of that number and squared it. We have half of that number and we square it. Good. It's well set. Now, what we're going to have to do is rewrite it in this form. The h, that number, 2 times that number is h, and we had h squared. What is our h here? Our h is really b over a. You see that? B over 2a, I mean, it's b over 2a. 2 times h. If we say 2h is equal to b over a, then h is b over 2a. And if we say h squared is b over 2a squared, then again h is b over 2a. So our h here that we show up here, we represent it as b over 2a. So what we're going to do here is say this is a times x plus h squared. So it's x plus, our h is the same as b over 2a, so it's b over 2a, close bracket, squared. Good, you see that? Alright? Now, let's get rid of these markings. Now, what we do here is going to fix this part up. So we say plus c minus a times, you see this b over 2ar squared, we can separate each letter and number and say it's b squared over 2ar squared is the same as 2 squared a squared equals 0. You see that? Oh, guess what? Look at this. A into a goes 1 time, a into a squared goes 8 times. So we can simplify it that way. So let's continue down here. We have a x plus b over 2a r squared plus c minus, this a is gone, we have b squared up top, b squared over 2 squared is 4, so let's just write 4 here. A equals 0. You see that? Let's draw a line right here instead of erasing anything yet. We don't want to erase anything yet to make space. Let's continue this over here. So what we have is a x plus b over 2a all squared plus c minus b squared over 4a equals 0. Guess what? We could add b squared over 4a to both sides, you know. Suppose we do that, what would happen? We would have equal sign here, and the b squared over 4a, b squared over 4a adds to 0, which just gives you the b squared over 4a. And guess what? If we subtract c from both sides, this would happen. Minus c. We're just condensing things because we don't have a lot of space to work with. Now, so we have a x plus b over 2a squared equal. Alright, now what we could do here, since it's a fraction, this is fraction, let's make the c over 1 as a fraction and work with that. Suppose we draw a line and find the LCM here. What we would have, let's draw the line here, find the LCM of 4a and 1. Remember how we subtract two fractions. The LCM is 4a, the LCM of 4a and 1 is 4a. 4a into 4a goes 1 time. 1 times b squared is b squared, minus 1 into 4a goes 4a times. 4a times c is 4ac. Okay, good. Now remember, we want x equal, so we're going to get rid of whatever we have up over the left hand side except the x. Now let's divide both sides by a. If we divide here by a, this over a cancels a. And when we divide the right hand side by a, this multiplied by a. But then 4a times a is the same as 4a squared. So let's put it that way, 4a squared. You see that? Then we have x plus b squared. Let's write that down. Let's put the x in a different color, since it's what we're aiming to end up with at the end. X plus b over 2a squared is equal to b squared minus 4ac over 4a squared. Alright, we now will have no choice but to erase something to make space. So let's erase what we have over here. Okay, now look at this. What we can do here is square root both sides. We find the square root of x plus b over 2a all squared, and we must square root both sides. The square root of all of this. Now when we square root all of this, there's something you have to remember. The square root of 4 is 2, but it's not only 2. The square root of 4 is a number that multiplies itself to give a 4. 2 multiplies itself to give a 4. But the thing is, negative 2 also multiplies itself to give a 4. 2 2s is 4. Negative 2 pi negative 2 is 4. So we can say the square root of 4 is positive and negative 2. That happens with any other number. So the square root of this is positive and negative. Alright? It's positive and negative that. So what we going to do is say the square root of any number squared is the number itself. You square a number and find the square root, you get back the number untouched. So what we have is x plus b over 2a equals, you see that? Alright, it's like the square and the square root cancel out each other and leave the number untouched. Equal plus and minus the square root of b squared minus 4ac over 4a squared. But guess what? You could separate the top and bottom. The square root of b squared minus 4ac over the square root of 4a squared. You see that? But guess what? The square root of 4a squared, you could separate that as well. You could say the square root of 4 times the square root of a squared. Alright. So what you have is x plus b over 2a equals plus and minus the positive and negative, the square root of b squared minus 4ac over square root of 4 is 2 and the square root of a squared is a. Alright. Now, at this point, you could say x subtract b over 2a from both sides. X equals. If you do that, you have plus and minus the square root of b squared minus 4ac all over 2a minus b over 2a. You see that? Then let's go over here and continue. I have to erase some of these things over here. Now we say x equals, if we have this plus and minus the square root of b squared minus 4ac over 2a minus b over 2a, you could find the LCM of 2a. It is 2a, and say 2 into 2a goes 1 time. 1 times plus or minus b squared minus 4ac is the same as plus or minus b squared, the square root of b squared minus 4ac minus 2 into 2a goes 1 time. 1 by b is b. Alright. So, that's what we have. Now, we can put the b in front and say that x equals minus b plus or minus the square root of b squared minus 4ac all my line is lean, all over 2a. And there we have it, the quadratic formula. So we've built the quadratic formula by completing the square of ax squared plus bx plus c equals 0. Good. So this is a formula that we can use to solve any quadratic equation. I will see you in the next video.